Question number 6 of JEE Main 2016. A satellite is revolving in a circular orbit at a height h from the Earth's surface. Radius of Earth r, where r is much greater than h. The minimum increase in its orbital velocity required so that the satellite could escape from the Earth's gravitational field is close to neglect the effect of atmosphere. Orbital velocity is the velocity that the satellite requires to revolve around the planet in a circular path. Centripetal force is also known as center seeking force. It's the force that pushes the satellite or any object in a circular motion towards the center. So it's given by mv square upon r, and force due to gravity is given by gmm upon r square. Since it is moving in a circular path, these two forces have to be equal. So if we equate these two forces, we get mv square upon r is equal to gmm upon r square, and which will give us mv naught for orbital velocity upon r plus h is equal to gmm upon r plus h whole square. If we cross multiply, we get v naught is equal to square root of gm upon r plus h. So v orbital is equal to, we know that force is equal to mass times acceleration. In this case, mass times gravitation, because the satellite experiences or accelerates at the rate of g. So this is mg should be equal to, force is equal to gmm upon r square also. So this will give you g is equal to m g. M will actually cancel out, m and m will cancel out, so you'll get g is equal to small g upon m multiplied by r squared. So if we substitute this value right here and take r plus h as just r, because h is too small to make any significant difference to calculations, and they've already said so in question. So we'll get v orbital is equal to square root of gr. V escape, you would remember, is square root of 2gr. So if the satellite is revolving around the Earth with v orbital velocity, and if it wants to escape the Earth's velocity, the extra velocity that will be required will be v escape minus the orbital velocity, which is square root of gr. So it already has this much velocity, it should have this much, so extra velocity will be this value minus this value, which will be equal to, you can take square root of gr as common and you'll be left with root 2 minus 1, which is the fourth option. So that's how you solve this question. If you want to see a more detailed explanation of this question or the solution, then I will give a link in the description. In that video, I have explained in much more detail on how we get orbital velocity, escape velocity, etc, etc. If you like this video and if you want to get updates from my channel, please subscribe to my channel and please comment below, and also please click on the like button.